All right, let's talk about order of operations when it comes to color management. This is something I see all the time. I'm going to go back. I'm going to go to our chart of where everything happens. And, in your normal, fully managed workflow, you're working with some kind of client, what I call client native space. Sometimes it's camera native, sometimes it's something else. Like if the pull house transformed camera native log into linear camera native or into aces or some other flavor or some other camera native log. If it's a B cam, they'll usually convert it to the A cam's color space so that LUTs and everything else play accordingly without having to have second sets. So we start in our client native space. We'll apply an input process or an IDT or a transform that goes from that defines our native space and pushes us into our working space. We do all our comp work in our working space. We have our ODTs for display space to show that footage the way it ought to be seen. And then usually you'll have a secondary one that will apply all the client color stack. In that case, we're usually going from working space back to camera native log. Then we're applying CDLs and we're applying show LUTs. And then unless you have a Rec 709 display, a lot of show LUTs are outputting to a Rec 709 space. You also need a secondary conversion from that Rec 709 space to whatever your display space is, typically sRGB for your standard artist, which is something that gets missed a lot. A lot of times they'll take that Rec 709 output and just view that directly as a viewer, in your viewer. And it's close, but it's not 100%. You need that little jump from Rec 709 to sRGB to properly display that. Because remember, your client's looking at it typically on a sRG or on a Rec 709 monitor in an edit bay, so they don't have they don't need that extra jump. And then similarly on the output, we're taking our working space, we're applying the inverse IDT typically, or whatever the defined spaces that they want renders in, and that's creating our client native space master deliverables. And then we're using that same client transform group where we're going back to native log, applying CDLs, applying show LUTs or display LUTs, and then rendering QuickTimes for offline display. What that turns into is talking about how we manage it. Like, we don't have to manage it that way. We can stay client native space the entire time. It simplifies things in terms of applying LUTs, because now you're not having to go from working space to get to LUT space. You can just apply a CDL and you can apply a show LUT directly. Where that makes a difference is, here's a source file. This is shot with a Panasonic in Vlog vGamut. In a perfect world, you're using full management. You can set your input transform to Vlog vGamut. Input Vlog vGamut. And now you are seeing an image that looks pretty much like you were standing there. In this case, I think there's a slight bit of, Panasonic vGamut there isn't a lot of color that's outside of gamut in this particular clip, but this is how it should look. And then from there, here are your other flavors. Sometimes if you're looking in, in terms of no management, log camera native looks like this. Linear camera native looks like this. And just as a refresher, so this is fully managed, and then this is linear camera native without gamut management. And then this would be linear display gamut. Which you can see looks very similar. It's basically looks the same as our fully managed. And then there's also working space. And in this case, my working space is set to linear sRGB, but this would be an image in ACES CG. So you can see versus the display, the working space is actually a little bit muted. And again, it's worth understanding, like, working space and display space are different. So what we see as saturated in a properly managed display space, the working space underneath that isn't quite as saturated. It's more saturated than the camera native space. And so like you can see, especially in the blue, so this is camera native, this is working space, that's display space. So we do get quite a bit more saturation out of some colors in our working space versus our camera native space. Definitely not as much as display space, but again, display space is much, much smaller than all the spaces we're talking about. So that's kind of the quick, like what the images look like with no management. And this is really the one I see a ton of. And then what I see happen is a showlet gets applied to this that pulls all the colors up and makes them look correct. But the problem is we're doing math on considerably more desaturated colors than we need to. So that's no management. Next we have implicit management. So we'd have our, log camera native gamut. Like if I tick the raw box on that, it looks like that. We set it to vlog v gamut, and now it looks like it looked if we were standing there. That same linear camera native file, we tell it the input is linear camera native, or linear v gamut, and now you can see it looks exactly the same as the other. Similarly, like if we received imagery that was linear sRGB, linear Rec 709, which again happens from time to time, we would tell it it's linear, and that lives under utility, linear Rec 709. And same with working space. So now it doesn't matter the input space, all of these look the same, and they look the way they're supposed to look, and that's the really important thing here. They're all converting into the working space, and so they all sample the exact same as well. And the fun thing here, it doesn't matter what your working space is. So right now we're set to linear sRGB. I'm going to set that to ACCG. And a fun thing here is you have to actually reload these for that color management to take effect. But now the same thing goes here. If we step through each of these, they all continue to look the exact same. We change the working space, nothing's changed. You will notice though, if you look at the sample, our sampling has changed. In this case, the samples, it's not quite as red as it was in that linear sRGB space. And lastly, say we want to be full native gamut, you can set your working space to your input space. So in this case, it would be linear v gamut. You see that little color flip? We just reload really fast. That'll redraw our thumbnails. And now, again, we can step through all 4 of our images, and they all look exactly the same. And again, now our color, we've lost a little bit more saturation in terms of our working space. So that's with full implicit management. Typically that's where you want to be, because now it doesn't matter, as long as you know the source, it's converting properly to your working space, and your working space is converting properly to your display space and showing you the image you expect to see. Now this is where it gets fun. You can do explicit management without a working space. You can do it via nodes. So I'm going to flip over to a different Nuke that's managed. So now we have our log, camera native, linear, display linear, and working space. If we're working, say you need to convert something and you don't have any color management available to you. Using what we know about color space, in that it's a transfer function, a white point, and a gamut, we can actually replicate that completely with nodes. So in this case, we can pull the white paper for vlog, and I've done that and basically I put the function for vlog into an expression node. So now we can go from log camera native to linear camera native using that transfer function. We're close, we're still not there. Now, say I want to go to linear sRGB instead of linear camera native, I can use a color matrix to make that jump to color native, or to, I'm basically going to sRGB display native here. So now we're looking at something that looks like it should look if we were there on the day. If we wanted to do work here, we can. sRGB, again, not the best working space because it is very small, and you run the risk of clamping and some other color bleed issues. But that's how you would take this image from log camera native to linear camera native to sRGB display native. And then to get it back, you would just do the inverse, and the white papers will supply a log to linear formula, and they'll also typically supply a linear to log formula as well. So you can inverse everything you did and wind up with an image that is back to where it started. Similarly, it all works kind of the same ways. Like we have our linear camera native, we would use a color matrix to convert it and go back. In this case, we're already in display space. Here, this is really more analogous to what we're doing in a fully managed space, is we have imagery that has now been converted into our working space, and our working space to sRGB is what's making it look correct at the display. And then again, we can invert that. So here's this is basically a comp where we're doing all the conversions explicitly. And this is what's happening under the hood usually, but you can also do this directly, again, if you're in a bind or in a spot where you don't have color management. You don't have access to, or it could be a color space that just doesn't exist. You know, D-Log, like DJI drone footage, some stuff gets shot in D-Log. D-Log doesn't have profiles readily available, and so there have been cases where we use an expression node to build D-Log and then use a matrix to convert from D-Log to our working space. So yeah, in this case, we'd have our log footage. Now we're all the way down. We're converted to ACCG, so we're linear, ACCG. We do all our work. Say we have something from a different source. So say we have an sRGB image pulled off the web. You would go from sRGB to linear. And then, again, really important, you have to convert everything to your working space. So you'd go sRGB to ACCG, do whatever comp work you're going to do, to wind up with your final image. And again, you're in working space, so you would need to you basically need an IP to convert that to the proper display space. Because at this point, everything's sitting in your working space. So here we have our sRGB source image as raw. We're going sRGB to linear, then we're going sRGB to ACCG. Doing our comp. We have a full comp in our working space. Our working space is then going ACCG. To get to our display, we need to go ACCG to sRGB. So now we're looking at an image that's gone through the pipe appropriately. Similarly with our client look, we need to go back. We need to back out of everything we've done. So we would back out to vgamut and then back out to log, apply whatever CDLs need applying, and then you would apply a manufacturer LUT or your show LUT client LUT, which is also doing like in this case, it's outputting Rec 709. Which in this case, you would also add you would want to go from, we know the output of that LUT is Rec 709. So we would go utilities, Rec 709 camera, and in our case, there is no working space here. So our utility, we'd go linear sRGB to get our proper sRGB Rec 709 transition. And then on the back side, we would back out of all the things we did. So we go ACCG back to vgamut, back to vlog, and that's our output. So that'd be a managed, fully managed ACES CG working space config. That's the nice thing. You just set the knob to what it's supposed to be, and it does all this under the hood for you. But that's what's actually going on. Here's what happens with an unmanaged workflow, and this is something I see a ton of, where you have a log CNG, log camera native footage or linear camera native footage. It just gets linearized. Similarly, you have your sRGB plate or your sRGB graphic. The graphic gets comped in, but the gamuts weren't converted. So this is an sRGB gamut. This is in vgamut, camera native log. They get comped together. And then there's typically not a gamut adjustment for the monitor. So if you look at it in standard sRGB, it just looks like this, which kind of looks okay. Like this sRGB is, all the colors are popping and sweet. But then you go to your client native thing, and this is crazy hot. Like all your saturation popped here because it did a gamut transform. So those really hot, those sRGB numbers that were about right, those are applied in the wrong gamut. If you were to apply an sRGB to vgamut conversion, all these mute up, and now the gamuts match, and what the show LUT does and what they're going to do in the color and the online, those all line up. So that's the big gotcha I see a lot with unmanaged gamut workflows, is you get this mismatch of gamuts with no explicit way to handle it, other than creating, adding color matrices or using OCIO color space nodes to help manage the gamuts explicitly.